Good afternoon. My name is Sam Baker, and in keeping with the revolutionary spirit of this conference, the title of my talk today is Less Control but New Understanding: What It Means to Reimagine Economics as a Natural Science. I'd like to begin my talk with a famous quote commonly attributed to Albert Einstein that has become a guiding principle in my work. It goes like this: we can't solve problems using the same kind of thinking we used when we created them. I love this quote because it helps us ask two key questions. What is the problem we are looking at, and what is the kind of thinking that got us there? This second question reminds us that solving deep problems often requires new kinds of thinking that transcend old patterns and assumptions. And this is a sentiment that could easily be the motto for this inaugural International Conference on Thermodynamics 2.0. That is because ICT 2.0 wisely recognizes that the institutional and conceptual dichotomies separating the social and natural sciences have become a hindrance to creative problem solving across many scientific disciplines and domains. Nowhere is this more obvious than in traditional mainstream economics, which remains solidly entrenched in the social sciences despite a century and a half of sustained efforts by the best and brightest in economics to build a bridge to the natural sciences by importing its conceptual trappings, including, and maybe most importantly, the sophisticated math and conceptual models of physics. This effort began in the 1870s when French economist Leon Walras borrowed the most sophisticated math of his time, the differential equations of calculus used in equilibrium physics, and set about developing a proper economic science that could predict economic outcomes and in so doing help policymakers control the economy. Since the very beginning then, modern economics had a congenital case of what some critics call physics envy. This brings us to an obvious but important point, and that is the problem we are aiming to solve here at ICT 2.0 isn't to just merge the social sciences and natural sciences per se. As I've just indicated, we've seen economics do this badly for a long time, over 150 years and counting. Rather, what we are collectively trying to do here is merge the social and natural sciences by finding the appropriate common scientific thread in the very special science of thermodynamics. And that is why I feel so grateful to be part of this conference, because it's exactly what I've been working at over the past 15 years. That is, using Rod Swenson's pioneering work in far from equilibrium thermodynamics to develop a conceptual framework for an authentic, or what I would call a native natural science of economics. Swenson's work dissolves the false dichotomy between the natural and social sciences, and consequently, our new natural science of economics opens up new problem-solving opportunities inaccessible to current mainstream economics. While my project offers positive evidence supporting the explicit premise of this conference that it will be thermodynamics that will help blaze a trail or trails merging the natural and social sciences, it is important to note that not all thermodynamics is created equal. In fact, we believe it is relevant and important to take a minute here to explain how thermodynamics led a notable strand of economics astray in the past and may risk doing so again in the future. The strand of economics we are referring to is Entropy Economics, launched in 1971 by Georgescu Roegen with the publishing of his landmark book titled The Entropy Law and the Economic Process. Georgescu Roegen's ideas resonated with the newly emerging environmental movement in the early 70s, including the Club of Rome folks, because it challenged a fundamental tenet of economic orthodoxy, that stable economic growth should be the measure of successful economic policymaking. Georgescu Roegen still resonates in the modern fields of political ecology and ecological economics, and in other neo-Malthusian frameworks such as the degrowth movement in economics, which has gained some momentum in recent years. John Cassidy, a staff writer for the New Yorker magazine and a well-known economics journalist, put it this way in his recent New Yorker article profile on the degrowth movement titled, "Can We Have Prosperity Without Growth?" open quote, "The critique of economic growth, once a fringe position, is gaining widespread attention in the face of the climate crisis," close quote. While we applaud Georgescu Roegen for rightly pointing out the fundamental theoretical limitations embedded in modern economics, including its erroneous grounding in classical mechanics and near equilibrium modeling, and we wholeheartedly agree with his criticisms there, Georgescu Roegen merely solved one problem to introduce another. He replaced the notion of a mechanistic equilibrium economy with an economy beholden to the second law. And this is where the story gets a little complicated, because Georgescu Roegen's Entropy Economics derived its logic not from the classical formulation of entropy as articulated by, among others, Clausius, Thomson, and Carnot, but instead from Ludwig Boltzmann's statistical formulation of the second law, which ironically attempted to save the Newtonian mechanical worldview of classical physics by reducing the second law to a stochastic collision function, which then led to what we would call an original sin in thermodynamics. That is the idea that the second law is a law of disorder. This in turn led to the erroneous idea, still very much entrenched in mainstream physics texts and science literature, and unfortunately even in the wider cultural milieu of our modern world, that the cosmos is running down to disorder. Georgescu Roegen picked up this logic and applied it to the economy, which he describes as, quote, "the ineluctable transformation of ordered natural resources into unusable waste," closed quote. Georgescu Roegen ultimately concluded that the economic process recklessly accelerated the disorder creation inherent in the second law, and warned that modern society risked imminent collapse as we mindlessly exhausted our fixed natural resource endowment on Earth through the pursuit of wanton and wasteful economic growth at any cost. This is an idea that still holds intuitive appeal and is once again fueling the latest resurgence of neo-Malthusian economic programs, including the degrowth movement mentioned above. The modern global economy may very well be unsustainable. In fact, we will argue below that economies follow a developmental life cycle, suggesting the exponential economic growth trend we've seen in the modern economy since the Industrial Revolution will inevitably end. But another post-industrial economy may launch in parallel, thus limiting any adverse impact on growth from the demise of our modern economy. More on that in a minute. The important point here is that we reject as untenable the unfortunately very sticky idea born from Boltzmann that the economy is inherently unsustainable as a result of a disorder imperative baked into the second law. There is no such imperative. And Rod Swenson shows us why with his universal ordering principle based on his formulation of the law of maximum entropy production, or LMEP, also known in the literature, though I would say not widely enough, as the fourth law of thermodynamics. Swenson turns the idea that the world is running down to disorder on its head by showing the opposite, that in fact, open quote, "the world is in the ordered production business," end quote. Swenson's universal ordering principle formulation gives us the intuition we need to understand why it is spontaneous order that is naturally emergent and ubiquitous in the cosmos. In other words, contrary to what Boltzmann claimed, the world is not running down to equilibrium. A more appropriate metaphor would be to say the world is running up to equilibrium, reflecting the fact that the world is striving, always and everywhere, to produce order. And this order occurs when a gradient differential across the system hits some minimum threshold. We may be able to forgive Georgescu Roegen for building an economic model on the erroneous idea of entropy being a law of disorder, as he was writing before the ideas of open systems and far from equilibrium thermodynamics gained traction in the 1970s. It is harder to justify the neo-Malthusians, who continue to focus on an erroneous reading of the second law in their attempt to demonstrate the hard material and energy limits of human economies. But even here, we may have some sympathy. This is because the idea that we can assume the world is running down remains, unfortunately, deeply entrenched, even within some of the most current physics and far from equilibrium thermodynamics literature. It is no wonder then that a neo-Malthusian economist or climate scientist might continue to assume the world is running down and thus running out of a fixed endowment of natural resources. Ironically, the original sin of modern economics may be described in similar terms to the original sin committed by Boltzmann that we are still having to deal with in physics today. That is the core simplifying assumption that the world is fundamentally mechanistic, or as Boltzmann specifically proposed, that it can be modeled as a gas in a box, modeled as billiard balls, or in the later version, as a near equilibrium isolated system made up of colliding particles. This is a world that ineluctably falls into disorder, and where Boltzmann erroneously asserted with upside-down logic that spontaneous order is infinitely improbable. In 2005, my search for alternative frameworks to the neoliberal or traditional economics consensus led me to a review of economic history and eventually to the classical liberal thinkers, including Adam Smith, who articulated verbal models and metaphors to describe what they deemed the unplanned spontaneous order formation of the newly booming industrial economies of the 18th century. A small side note is worth a minute here to point out the irony comparing how these brilliant minds observed qualitatively that spontaneous order emerged naturally in society, whereas another brilliant mind, Ludwig Boltzmann, claimed his statistical formulation of the second law proved quantitatively and scientifically, and we would also add erroneously, that spontaneous order was infinitely improbable. This reminds us of a long-time criticism of traditional economics, that it fits the world to the model, not the other way around. Adam Ferguson, who was a contemporary of Adam Smith, described the spontaneous order of the economy and supporting institutions as follows. Every step and every movement of the multitude, even in what are termed enlightened ages, are made with equal blindness to the future, and nations stumble upon establishments which are indeed the result of human action, but not the execution of any human design. Adam Smith invented his infamous metaphor, the invisible hand, to describe his concept of spontaneous order manifesting in the newly industrial economic world of his time. The notion of spontaneous order applied to socio-economic systems intrigued me, and my further pursuit of the thread of the idea through economic history brought me to the Austrian economics tradition, and specifically Nobel laureate F.A. Hayek, who famously updated and elaborated the spontaneous order tradition of classical liberalism for the 20th century. The recurrent theme of spontaneous order in economic and intellectual history made me wonder if the concept might have a natural law explanation available somewhere out there. Shortly thereafter, in 2006, I discovered Rod Swenson's landmark paper, Autocatakinetics, Evolution, and the Law of Maximum Entropy Production. The law of maximum entropy production offers exactly what I was seeking, a natural law-based explanation for spontaneous order. This paper is a summary of what I've done over the past 15 years to integrate Swenson's ideas with the intuitions of the spontaneous order tradition in economics that I mentioned above. The first major conceptual breakthrough for me, thanks to Swenson's paper, was the realization that the economy can be classified as an autocatakinetic system, which I'll refer to going forward as an ACK, spelled A-C-K. ACKs are members of the class of natural systems that display emergent, self-organizing, net entropy maximizing behavior. As Swenson explains in his above-mentioned paper, quote, Living systems, from bacteria to cultural systems, are self-organizing or spontaneously ordered systems defined by dynamic order, their identity constituted through the incessant flux of their components, which are continuously being replaced from raw materials in their environments and expelled in a more dissipated form. End quote. Note how similar this definition sounds to what Georgescu Roegen warned was wrong with the human economy. Viewed through the ACT lens, material and energy dissipations are no longer a sign of the end of the world. Other notable and profound implications of this ACT classification system on our new natural science of economics are worth mentioning here. Consider for a moment the following quote by Nobel laureate Paul Krugman. Open quote. One of my favorite John Maynard Keynes quotes comes from Essays in Persuasion, in which Keynes tried to explain the nature of the Great Depression, which was still in its early stages, when he declared that we have magneto trouble. A magneto is the old name for an alternator, a starter. Continuing now with Krugman. The economic engine was as powerful as ever, but one crucial part was malfunctioning, the magneto, and it needed to be fixed. Anyone know a good mechanic? End quote. This quote highlights the dominant mechanical fallacy that is hardwired into traditional mainstream economics through its origin roots in classical physics, which promotes an interventionist, centralized, command and control policy-making orientation. Now, one word of added nuance here. It isn't wrong to say that ACT systems, like the economy, exhibit certain machine or mechanistic-like qualities, especially as the system ages. In fact, Ludwig von Bertalanffy coined the term progressive mechanization to describe the process of the progressive freezing out of the degrees of freedom of a complex open system over its life cycle. However, we do think it is unfortunate that Bertalanffy opted for the machine metaphor, progressive mechanization, to describe a fully natural process that could be more aptly described as progressive determination. As Keynes' magneto metaphor described above demonstrates, it is all too easy to push the machine metaphor too far, and thus we believe far from equilibrium thermodynamics is better off avoiding machine metaphors altogether. After all, one of the important takeaways of Swenson's ACT classification scheme is that nature is fundamentally not a machine. Another generic feature of ACT systems that we may apply to economics in a fruitful manner is the fact that they appear to launch. This occurs when the ACT's source sink gradient exceeds the minimal critical level sufficient to pump up or fill out the new dimensions of spacetime that the establishment and maintenance of the ACT entails. At the moment of launch, the system goes through a symmetry-breaking phase change. If we apply the generic model of an ACT system launch to the economy, a theory of origin for the human economy literally falls out of this analogy. According to Eric Beinhocker in his wonderful book, The Origin of Wealth, quote, questions of origin play prominent roles in most sciences. Yet the question of origin of economies has not played a central role in traditional economics. Traditional economics has tended to focus on how the economic pie is allocated, rather than how the pie got there in the first place. Even traditional growth theory implicitly begins with assume an economy. The process of economy formation presents us with a first-class scientific puzzle, end quote. Once again, insights gained using knowledge of the generic features of ACTs to help understand the economy solves very simply what presents as a deep puzzle to traditional economics. Another long-standing puzzle for traditional economics, which falls right out of another generic feature of ACTs, is a theory of productivity. One definition of productivity is simply the ability to get more output out of the same inputs. In order for an ACT to maintain its structured order, it continues to access new dimensions of space-time at some sustained rate. The ability of acts to access new dimensions of space-time is another way of saying the system is able to increase its productivity. Thus, we propose that simply classifying the economy as an act offers deep insights about the source and sustainability of structural productivity growth and in turn of economic growth, which is ultimately bound and supported by productivity growth. We have several other deep insights we've developed by applying the act classification to economies. Given time limitation, we'd like to share one last one today. What we know about highly complex and nested act systems, such as the paradigmatic example of the climax forest system, is that they follow predetermined life cycle stages. In the example of a forest system, the stages follow the following pattern: birth, an exponential growth stage called the pioneer stage, maturity, decline or senescence, and death. We can safely assume by way of this direct analogy that economies also follow developmental life cycle stages. The standard S-curve shape of the logistical growth equation provides an analog to the act life cycle stages. And so too we propose for economies. One of the great empirical puzzles for the US economy, and similar findings are available for other economies, is that real GDP growth has been remarkably faithful to a 1.8% real GDP growth trend since 1870. There are wobbles around the trend line and occasional big dips, like with the Great Depression, but the trend line has always reverted back to trend. This is another profound mystery for traditional economics that, again, literally falls out of the logistical growth equation life cycle model. The straight line graph of GDP growth rate trend for the US economy over the past 150 years is the second derivative of the exponential growth phase of the logistical growth equation, which maps to the high growth or pioneer stage of the ACT life cycle model. My personal view is that we are towards the end of our exponential growth stage, and thus average GDP is likely to hit a discontinuity and reset to a shallower trend line going forward. And we may already be there. The historical slow growth recovery and below trend structural productivity measures for the US economy after the 2008 global financial crisis has led to speculation by a number of prominent establishment economists that we had entered a period of secular stagnation, which is a fancy way to say the economy won't grow as fast as it has in the past. Meantime, the Congressional Budget Office recently published a study forecasting that US GDP will decline from 1.8% to 1.6% over the next 25 or 30 years. Neither piece of evidence is definitive, but it is suggestive of the economy aging. And we have more evidence. The well-documented trend of rising income inequality in the US and in many other developed economies is another piece of circumstantial evidence, in addition to the slowing growth story mentioned above, that the US and perhaps the global economy is aging into a slower growth developmental life cycle stage. Going back to the climax forest analogy, in the maturity to declining life cycle stages, larger trees begin to crowd out lower subcomponents of the forest system. Consequently, degrees of freedom of the system are frozen out as throughput on which the ecosystem depends is effectively shunted and sequestered in the largest trees, and especially in the non-productive parts of those large trees, that is, their trunks, much of which is dead. In economies, this shunting and sequestering dynamic shows up as growing income inequality and increased market concentration and consolidation, as we've seen play out in many markets, including finance, technology, and media, which are dominated now by a handful of mega corporations. As the ACT system continues to age, it becomes fragile and brittle, such that it is vulnerable to systemic collapse from ever smaller perturbations, such as a fire or a disease that wouldn't have posed such a risk in an earlier life cycle stage. We believe evidence of such endemic brittleness in the world economy has been highlighted by the COVID-19 pandemic, which has revealed a lack of resilience and even outright weakness or failure across political, social, and economic institutional dimensions and domains. We hope you agree with us after the above treatment that properly classifying economies as acts offers profound, parsimonious, and intuitively attractive insights about economies not available or in some cases even contradicted by the traditional economics paradigm. The developmental aspect of our model is a key advantage over the prevailing mainstream macroeconomic theory, which relies on steady state or equilibrium models that require extremely unrealistic assumptions, such as perfect rationality and foresight of consumers, as well as ad hoc explanations for exogenous variables such as productivity and time. Our AC/LMEP-based natural law-based theory of economics has a theory of origin, a theory of productivity and growth, and a developmental life cycle framework all built into the hard core of the theory, meaning these features are endogenous rather than ad hoc or exogenous or just plain missing, as is the case in traditional economic theory. Adam Smith's notion of the invisible hand has been pilloried and even rejected out of hand as being an unscientific, outlandish metaphor divorced from reality. However, my research suggests this long-suffering metaphor deserves reappraisal, given what we now know about the latest developments in far-from-equilibrium thermodynamics, including LMEP, and what flows from LMEP, that is, Swenson's universal ordering principle, and the conclusion that the world is in the order production business. The policy implications. Our research suggests that the best public policymakers can do is avoid implementing policies that accelerate the natural aging process of the economy. The Hippocratic Oath comes to mind: do no harm. Treating the symptoms of dysfunction in the human body and the body economic are similar to the extent that both require a profound appreciation for the law of unintended consequences related to the potential adverse second or third order effects of the well-intentioned treatment of superficial symptoms. One big difference between humans and economies, however, is that we know the physical lifespan of humans, yet we do not know the natural life cycle span of the modern human economy. The best we can do is use circumstantial evidence to judge where we are in our economic life cycle. As mentioned above, hints of slowing structural productivity, slowing average GDP growth, rising income inequality, and market consolidation all point towards an aging economy. Our conceptual model indicates that interventionist policy measures aimed at ensuring improvements in the economy and financial markets may be counterproductive if, as they often do, reduce the microstochasticity of the economy, thus freezing degrees of freedom in the process and therefore aging the system or the economy even faster than otherwise would have been the case, bringing on early brittleness and decay in the economic system. Now, having laid out my argument that a developmental model for the economy is appropriate and useful, I'd like to make an important point of clarification. I'm not saying human civilization is inevitably headed for collapse. An economy is not exactly like a forest ecosystem. Unlike a human economy, a climax forest ecosystem has more or less fixed interaction rules, and thus also has a more or less fixed developmental stages. The birth stage in a forest system can't happen until the old forest dies. We posit that a new economic system with a new set of interaction rules, what might be called a new operating system for the economy, could spontaneously emerge or launch, in our terminology, in parallel well before our current economic system heads into senescence or collapse. To fully elaborate this point would require a separate talk. Suffice it to say here that this new system cannot be designed, planned, and created as a human engineered entity or structure ex nihilo, but rather would have to emerge and launch spontaneously, like all natural, spontaneously ordered act systems, including its act predecessor, the modern capitalist industrial economic system as we currently live in and experience. One final policy implication. The policy variable that we believe has the largest impact on the pace of aging in the human economy is a core feature of modern capitalist economies. That is central banking and its associated inconvertible government monopoly fiat money regimes. This is an enormous subject that we also cannot do justice in this presentation. But here are a few brief comments. Swenson's ACT model helps show that non-commodity-backed fiat monetary systems like we have today age the economy by effectively decoupling a conserved quantity from an unconserved quantity. That is, a finite commodity like gold is replaced by unbacked fiat money. Such a decoupling facilitates generic and self-destructive behavior in the economy. For example, resource shunting and sequestering, as often manifest in, as we've mentioned, in increased wealth inequality, as well as in exaggerated boom-bust cycles, both of which we have seen repeatedly and quite dramatically play out over the past 20 years. The issue of climate change may also be explained by excessive order production, what economists call GDP growth, which has been facilitated by massive central bank money printing. And this is clearly evidenced by an explosion over the past 20 years in global debt levels, both private and public. Since order and disorder production is coupled as per LMEP, the law of maximum entropy production, it is no surprise that the excess order created by central bank fiat money printing, and that order is, again, what economists call economic growth, has been associated with exaggerated disorder, and this in the form of CO2 emissions and other systemic environmental stresses. In conclusion, the quest by the best and brightest in the mainstream economic establishment for a natural law to explain market economies has long been underpinned by the assumption that if only such a law could be found, it would facilitate society's effective management of modern markets via deterministic and thus predictable laws of nature, in the same sort of way that Newton's laws provided a basis for important new technologies that allowed humankind over the past 3 centuries and counting to radically improve society's control of nature, and in so doing improve the general welfare of humankind. Ironically, the theoretical framework we have developed and briefly introduced here relies on a natural law with tremendous explanatory power that by definition has no direct predictive power, at least in the Newtonian Laplacian sense. The future becomingness of natural autocatakinetic systems, like the Earth system, or subsystems of the Earth system, like the human economy, cannot be predicted ex ante. This is so because the world is not deterministic, again, in the Newtonian Laplacian sense. We know that nature strives for entropy maximization, but we cannot know ex ante which path will take us there. Only in the very process of becoming can a human economy or society keep piggybacking on the productivity engine provided by the fourth law. To try to predetermine which path will get us there paradoxically ensures the freezing of degrees of freedom of the system and early demise or even death. In closing, if you take just one thing from this talk, I hope it is this. Comparing the economy to a car or a machine is a profound category error and dangerously misleading. Thank you.
Sam, maybe you want to go next?
Do you hear me now?
Yes.
Okay. So I just wanted to say to the last presenter, I enjoyed that presentation very much. I think you'll notice some echoes of what you were talking about in my talk. So good afternoon, everyone. My name is Sam Baker, and in keeping with the revolutionary spirit of this conference, my talk today is entitled A New Natural Science of Economics. I'd like to begin my talk with a favorite quote of mine, commonly attributed to Albert Einstein. We can't solve problems using the same kind of thinking we used when we created them. There's some debate whether Einstein actually said these words, but leaving that aside, this quote could easily be the motto of this inaugural ICT 2.0 gathering, and why I'm so delighted and grateful to be here today with like-minded scholars united by a common interest in using thermodynamics to help bridge, or better yet, merge the natural and the social sciences. What I love so much about the Einstein quote I shared above is that it leads us to ask two key questions. First, what is the problem we are talking about? And second, what is the kind of thinking that led us there? As you probably guessed from the title of my talk, the problems I'm focused on today are economic problems, some of which are urgent. For example, recurrent global financial instability and rising income inequality. Other economic problems may even pose existential risk to human culture, namely climate change, ocean acidification, and other related environmental degradations. The stakes are high indeed. I will argue in this talk that a new natural science of economics based on far from equilibrium thermodynamics can help shed light on a new way of thinking about these seemingly intractable global problems, such that we may be led to a more creative and a more humble way to address them.
Say, Sam,
Yes.
one question, are you screen sharing right now? Because I don't see your PDF, your PowerPoint, your screen.
I don't have a PowerPoint.
Oh, okay.
Yeah, that's what I assumed.
Yeah.
Yeah, that's good, Sam. Go ahead.
Okay. So in the wake of what has been effectively a rolling shutdown of the global economy due to the COVID pandemic, there's been a marked reduction in global CO2 emissions and air pollution. Satellite photos of China during their shutdown showed something striking: clear skies across the country for the first time in recent memory, which some climate activists have used to advocate that we shut the world economy down to save the world from CO2 emissions. As hopefully will become clear as I continue with my talk, the assumptions embedded in this line of thinking entail similar erroneous assumptions that got us into our economic messes in the first place. In general terms, the problematic thinking is mechanistic, reductionist, fix the symptoms approach. The specific kind of thinking in economics that got us into the current mess goes back to the second half of the 19th century, when what we might call the original sin of modern macroeconomics occurred. That is when the French economist Leon Walras borrowed the most sophisticated math of his time, the differential equations of calculus used in equilibrium physics, and set about developing a proper economic science that could predict economic outcomes, and in so doing help policymakers control the economy. For the purposes of this talk, it is somewhat ironic that this original sin I'm claiming for economics is in a sense exactly what we are all doing here at ICT 2.0, merging or bridging the natural and social sciences. So let me take this opportunity to make an obvious but a very important point. It is critically important that we choose the right natural science before using it as a model for any social science, including economics. While I agree with the implicit premise of this, or explicit premise of this conference, that thermodynamics will undoubtedly help blaze a trail for merging the natural and social science, even thermodynamics can lead us astray. And one example of this is entropy economics. Nicholas Georgescu-Roegen published a book in 1971 titled The Entropy Law and the Economic Process. It was considered a revolutionary work at the time as it challenged fundamental tenets of economic orthodoxy, especially the idea that stable growth is the key to policy making. It's a book that still resonates in the modern field of political economy, ecology, and in other neo-Malthusian frameworks. While Georgescu rightly pointed out the limitations embedded in modern economics, that is, its erroneous grounding in classical mechanics, and we wholeheartedly agree there. He merely solved one problem to introduce another. He replaced the notion of the mechanistic economy with an economy beholden to the law of entropy, the law Georgescu used to describe the economic process as the ineluctable transformation of ordered natural resources into unusable waste. So Georgescu posited the second law showed that we humans were at risk of using up the natural endowment of resources on Earth because economic growth accelerated the natural, irrevocable, and ineluctable process whereby the Earth is entropically winding down. And he therefore concluded that our current economic system is not just unsustainable, but urgently so. This is the heart and soul of the neo-Malthusian tradition that is still alive in many traditions related to the offshoots of Georgescu's Entropy Economics. The modern system may in fact be unsustainable, but I will argue it is not because of the second law. The story of the ineluctable process of the cosmos running down from order into chaos is only half the entropy story. The other half of the story is the one told by Rod Swenson, who's a speaker in this conference with his law of
Sam, looks like you're breaking up.
product, though not widely enough, I would add. Okay, Rod Swenson tells with LMEP, and Rod is speaking in the conference tomorrow, so I encourage you to listen to his talk. Rod's idea of LMEP, the law of maximum entropy production, helps show that the world is in the order production business. It turns out that the natural world spontaneously winds up into order and winds down into positive entropy, and this is simultaneous. This shows the fundamental error in building an economics exclusively on the intuition of the second law, the entropy law. We may be able to forgive Georgescu, who was writing before the ideas of open systems and far from equilibrium thermodynamics gained popularity in the 1970s. But we can't be so indulgent for modern neo-Malthusians who continue to focus on the second law and fatally misclassify the economy and the larger Earth system as a closed system with finite material and energy resources. So the original sin, I would say, of traditional economics may also be described in similar terms as the fundamental misclassification of the economy as a closed system. Now, this is critical. In 2005, my search for alternative frameworks to the neoliberal or traditional economics consensus led me to a review of economic history and the Scottish Enlightenment thinkers, including Adam Smith, who articulated verbal models and metaphors to describe what they deemed the unplanned, spontaneous order formation of the newly booming industrial economy of the 18th century. Adam Ferguson, who was a contemporary of Smith, described the spontaneous order of the economy as follows. Every step, every movement of the multitude, even in what are termed enlightened ages, are made with equal blindness to the future. And nations stumble upon establishments which are indeed the result of human action, but not the execution of any human design. This is what Adam Smith called the invisible hand. This notion of spontaneous order intrigued me, and I picked it up in the Austrian economics tradition, and specifically with F.A. Hayek, who elaborated on this spontaneous order tradition. So with this interest in spontaneous order, I wondered if there might be a natural law that might explain this. And shortly thereafter is when I discovered Rod Swenson's landmark paper, Autocatakinetics, Evolution, and the Law of Maximum Entropy Production. So for the last 15 years, I've been melding Rod's ideas with the intuitions from the spontaneous order tradition I mentioned. The first major conceptual breakthrough for me, thanks to Rod's paper, was the realization that the economy can be classified as an autocatakinetic system, what I'll refer to as ACK or an ACS going forward. ACS are members of, according to Rod, the class of natural systems that display emergent, self-organizing, net entropy maximizing behavior. As Rod explains in the above mentioned paper, living system or system defined by dynamic order.
Sam, looks like you're breaking out for me. I'm not sure what's for all.
Yeah, he's breaking. Sound's cracking.
Yep.
No sound.
I'm sorry about that. I don't know what to do.
Maybe if he turns off his
Sorry
video,
about
since
that.
it's
Let
an
me
audio
see.
presentation, may help.
Should we
Maybe it's
possibly,
I'm sorry, my connection is not. Does that work?
should we take the next presentation on while he adjusts his connection?
Okay, I can try that.
Okay, so maybe let's take the third presentation,
Okay, sorry about that. Thank you.
okay.
Let me try to fix my connection.
Okay.
I mean, he sounds okay now. What would you suggest? I mean, he can finish off.
You want me to?
I think it's better Sam continue now.
Yeah.
All right. So anyway, what I was talking about was the ACT system. I mentioned it. The definition is basically what Georgescu Rogan warned that the economy is guilty of doing. So the implications of the ACT
Sam, it's not working, and I request Nathaniel to stop this presentation and let's go to the next. And
All
I'll
right.
find a place for Sam later.
Okay.
Can you hear me?
You are breaking out.
Oh, forget it. I'm sorry.